Today we will look into the limit of a function fx when x tends to very large values, that is the limit of a function at infinity. To understand this, have a look at this function y equals 1 over x squared. If we find the values of x versus y, we can see here that as x approaches larger and larger values, y becomes closer and closer to 0. We can also see it in our graph here. When x tends to larger values, y becomes closer and closer to 0. This means that as x tends to infinity, y tends to 0. This can be written as limit of 1 over x squared as x tends to infinity is equal to 0. In general, we can write this as limit of f of x as x tends to infinity is equal to L. This means that as x becomes more and more larger, fx becomes closer and closer to L. In the above graph, we can also notice that when x approaches larger negative values, y approaches 0. So as x tends to negative infinity, y tends to 0. We can show this with our limit notation as limit of 1 over x squared as x tends to negative infinity is equal to 0. The general notation of this will be limit of f of x as x tends to negative infinity is equal to L. Here in this graph, the x-axis or the line y equals 0 is called a horizontal asymptote because the limit of 1 over x squared tends to 0 as x tends to infinity. Similarly, we can see here that the line x equals 0 or the y-axis is a vertical asymptote. Also remember that this symbol is not a number. It only represents relatively large values for a given question. Before moving on to questions related to this, we need to understand one rule when it comes to limits. Have a look at these graphs. Y equals 1 over x, y equals 1 over x squared, and y equals 1 over x cubed. We can see here that the limits of these functions as x approaches infinity is equal to 0. Similarly, when x approaches negative infinity, the limit of these functions are 0. So we can generalize this as limit of 1 over x to the power k as x tends to positive or negative infinity is equal to 0, where k is a positive integer. This property is widely used when solving questions. Now let's learn how to evaluate limits at infinity. Take this example. Limit of x cubed plus x squared plus 1 divided by x cubed minus 2x plus 3 as x tends to infinity. Our first step is to take the highest power of x out from both the numerator and denominator. For the numerator, the highest power is x cubed. So we take x cubed out of the numerator. So this gives us x cubed into 1 plus 1 over x plus 1 over x cubed. To check this, we can multiply x cubed back into this to see whether we get the same value as before. So x cubed into 1 will give us x cubed. X cubed into 1 over x will give us x squared. X cubed into 1 over x cubed will give us 1. So that means we have done this properly. And we take the highest power of the denominator out. So here it is also x cubed. So when we take x cubed out, we get x cubed into 1 minus 2 over x squared plus 3 over x cubed. Now we can cancel off x cubed from the numerator and the denominator. If you remember, we must mention x is not equal to 0 when cancelling this off. But in this case, since we are worried only about very large values of x, we do not have to mention x is not equal to 0. We can just continue without mentioning this. So after cancelling it off, we get 1 plus 1 over x plus 1 over x cube divided by 1 minus 2 over x squared plus 3 over x cube. Now we use our direct substitution method. So from the rule we learnt just now, 1 over x as x tends to infinity is equal to 0. It's the same for 1 over x squared and 1 over x cube. So we will get our final answer as 1 plus 0 divided by 1 minus 0 plus 0. So this gives us 1. That is how you answer questions related to limits at infinity. Try doing the questions given in the description below. The answers are also given for your reference. Until we meet again, take care.